Okay, we only have one vocab word today. It's kind of nice in section 2.6, and that vocab word is fancy Scrabble points. A lot of Scrabble points. Multiplicative inverse. Multiplicative inverse. Really, it's just a fancy word for the reciprocal.
I used to love that word.
Which is even a fancy word for flip.
Why is the box so big?
Why is this box so big?
Kind of expected a lot.
If you saw the definition they wanted me to give you, you'd be really thankful that I gave you this one.
How long is it?
It's that big. Yeah. I like my definition better.
Isn't it only when you take like, if it's like 2 6, you just put the 6 on top of the 2? They want,
Yep, they wanted to define it with that much stuff. I said, no way, let's just define it this way. So if we jump to an example, okay, example 1, identify the multiplicative inverse and justify your answer. Who thinks they know what the flip is of 9? So if you flip the fraction, Conrads.
1.
Not 1. What is 9 as a fraction, Conrads?
1. Wait.
9 over?
10.
Yeah, 9 over 1. 9 is just, anytime we have an integer we can write as a fraction, we can just write it over 1. Now flip it. 1 over 9. Okay. Now the official reason, the part that I didn't have you write in that big justification piece, the big definition, two numbers are going to be multiplicative inverses of each other if you multiply them and you get 1. So if I took 9 over 1 times 1 over 9, what do you get there?
9 over 1. Or 9 over 9.
You get 9 over 9, which is 1. Anytime you multiply a number by its inverse, you're always going to get 1. How about negative 5/6? Who think they know what the flip of that is, the reciprocal?
Negative 6 over 5?
Yeah, negative 6 over 5. Sometimes people say it's just 6 over 5. Well, we have to include the negative because what happens when we take negative 5/6 times negative 6/5? What do the negatives do to each other?
Because it, like, chop.
Yeah, the negative times the negative creates a positive. The 5s and 6s cancel, so we get, again, we get positive 1. If we didn't include the negative in the inverse, then we get negative 1, and then it doesn't fit the definition, and, well, that's just not good. Okay, let's take a second. You guys try to find the checkpoints 1, 2, and I added 3 and 4 up there. I want you to try to come up with the multiplicative inverse. Who's got number 1? If we flip it, Taishana.
Negative 3 halves.
Negative 3 halves, very good. You flip the fraction. How about 3? Julia? 1/3, because if you flip 3 over 1, you get 1/3. Now, a little more challenging, number 3 and number 4. Let's skip number 4. Let's just try number 3. See if you can find the multiplicative inverse of number 3. When you think you got it right. So when we look at number 2, here's the most common mistake I see. People go, well, it's 2 and 2 5/3. I flipped the fraction. But remember, when you take a number times its inverse, you always should get 1. If I take this number 2 3/5 times 2 5/3, heck, ignore the fractions for a second. What's 2 times 2? 4. There's no way I'm getting 1 out of that. What's the trick that you have to do before you can find the multiplicative inverse when you're dealing with a mixed number, Riley?
Actually, I don't know.
That's okay. Okay. Taishana, what do you got to do?
You make it a mix now. Well, yeah, no, it's improper.
Make it improper. So we take 2 wholes. So 2 times 5, I've got 10 plus 3, I've got 13 fifths. Now I can flip it. 5/13 is the inverse, okay? All right, so when we talk about division, well, let's see. Jump to this spot right here, the inverse property of multiplication. This is just kind of rehashing what we've already talked about.
Where is it?
I think it might be the previous page. Previous page. The product of a non-zero number and its multiplicative inverse. When we take a number times its inverse, what do we say we always have to get? 1. Any number times the flip is going to be 1. Now, technically, A can't be 0. I'm not going to get into that right now, but basically, you can't say A is 0 because, hey, you can't divide something by 0. We'll talk about that another day. An example, 4 times its inverse, 4 times 1/4 is 1. All right, jump to the sign of a quotient. Division, when people say, hey, Mr. Hilliard, I'm really good at multiplication, but I'm not very good at division, I say baloney. Because just like subtraction is glorified addition, division is glorified multiplication. So if you say I'm really good at multiplication, then I say you have to be good at division then too. Because division, quotient acts a lot like multiplication. If we take the quotient of two real numbers with the same signs, if I take a positive divided by a positive, like 10 divided by 5, is it going to be positive or negative? It's positive. It's positive 2. Okay, but what if I took a negative divided by a negative? Ignore the negatives for a second. What's 10 divided by 2? Or 10 divided by 5? How many negative symbols do you have? And when you have two negatives, what do you got to do? Chop, chop. So whether I take positive, positive, or I take a negative, negative, my answer is always going to be positive. But what if they're different symbols? Then it's going to be negative, because if we used our example again, let's say I took negative 10 and divide by 2. Ignore the negatives. 10 divided by 2 is 5. How many negative symbols do you have? 1. Oh, okay, so my answer is going to be negative. But how about this? The quotient of 0 and any number.
0.
Bam. If I've got $0 in my pockets and I split it between you two, how much do you each get?
0.
If I've got $0 in my pocket and I split it amongst you 10, how much do you each get? You would like $5, wouldn't you? I'll pay you $5 to make me homecoming pants next year.
Okay.
Okay? Deal?
Deal.
We've got witnesses.
Okay.
Okay?
Deal.
Witnesses.
Guaranteed.
All right, so let's jump to dividing rule. Now we talk about your division rule. This is where Colonel Sanders comes into play. All right? If you like Kentucky Fried Chicken, you better like division. To divide a number by a non-zero number, remember I said division is glorified multiplication. To divide, multiply by the inverse. So if I say, hey, I'm going to take A divided by B, that's the same as saying take A times the inverse of B. Okay, B can't equal 0. Again, I'll get into that another day, not for today's discussion. What's another way you can think of 7 divided by 3? 7 times what?
Times 3?
No, 7 divided by 3 and 7 times 3 would be very different things. But dividing is the same as multiplying by the reciprocal.
7 times 1 over 3.
Okay, and here's why I have Colonel Sanders up here. You guys may have talked about it last year, but you got KFC, right?
Yes. Oh, yeah.
Keep the first number, flip the second number. Okay, so I kept 7. I flipped 3, so it was 1 over 3, and then I changed the symbol. Keep, flip, change. I changed the symbol from division to multiplication. And this is really big when you're talking about dividing by fractions, because dividing itself is not very fun sometimes, but dividing by a fraction is a really pain in the butt. Okay, so let's take a look at example 2. How could we think of 25 divided by 5?
Well, you can do KFC.
So keep this, flip 5 is
1/5.
okay, and now you know what? I think it's easier just to think about it. 25 divided by 5 when you have integers, you're going to get
4. No, 5.
5. But when you deal with fractions, can you imagine trying to figure out how many times 2/3 goes into negative 40? That's tough. So instead of thinking of it as divide by 2/3, we could think of it as times what? What do you think, Tipka?
3 over 2, which is 1 1/3.
1.5. But you know what? Let's not even worry about converting it to 1.5. So we kept the first number, we flipped the second number, and we changed the symbol from division to multiplication. Well, you know what? This isn't so bad. What's negative 40 times 3? Negative 120. What's negative 120 divided by 2? Negative 60. That wasn't so bad. But if we think of it as division, it's ugly. If you think of it as multiplication, it's not too bad. All right, let's get you guys to try checkpoint problems 3 and 4. All right, somebody walk me through what they did in number 3. Kendra, what'd you do in number 3?
Wait. I flipped 3 fourths.
So you multiplied by 4/3?
Yeah.
And then what'd you get?
And then, then I reduced the 4 2, 2.
Oh, okay, so you recognize I've got a 4 on top and a 2 on bottom, so that reduces to 2 and 1.
Yeah.
So 1 times 2 gives you?
2.
And 1 times 3 gives you?
3.
Excellent. Okay, somebody walk me through what they did in number 4. Stuart.
Alright, so keep the first, so 16 over 1
Yep.
times 4 over 1.
Times the flip, right?
Yep.
Okay. And we've talked about it before. Just make sure when you're dealing with the negative symbol, you could give it to the 1, you could give it to the 4, but can you give it to both? No, because if I put negative, negative, it would chop into a positive, and it's a negative 1/4. I don't care which one you give it to, you just have to give it to one. I usually like to give it to the numerator at the top. Okay, so Stuart, what'd you do next?
Then take 16 times -4, which is 64.
Negative 64,
Over 1.
which reduces to? You got it. Excellent. Okay, very good. All right, now the last idea for today, earthquake it. You're going to hear me use this term quite a bit this year, earthquake it. Jump to example 3. See, earthquake it, the reason I call it earthquake it, you're given an expression like this, 48y minus 32 divided by 8. Now, the book teaches it to you this way. They say, well, division by 8 is the same as multiplying by the reciprocal, 1/8, right? And then you could use the distributive property that we've practiced. What's an eighth of 48y? When you take an eighth of something, you're dividing it by 8. So what's 48y divided by 8? 6. So we've got 48y times an eighth, which is 6y. And then we got to take an eighth of negative 32. What's negative 32 divided by 8? Negative 4. Now, that's how they like to teach it. I like to teach it earthquake style. Okay? So you're sitting there, you're a hoster or a hostess at a restaurant. No, you're a, what do you call them? The waitress. Waiter or waitress. Here you are, you're carrying your tray around, right? You got your little skinny arm, and you're balancing all that stuff up on the plate. Earthquake happens. What happens? It all comes tumbling down. Okay? So earthquake, here's what I like to think. Earthquake splits everything up, and all this stuff is going to come crashing down on the 8. What's 48y divided by 8? 6y. What's negative 32 divided by 8? Same answer, different way of approaching it.
That was so much.
I think earthquaking it's a lot easier, a lot faster. Okay, let's have you guys practice one here. We're going to skip number 5. I want you to try number 6 and 7. Okay, see if you can earthquake those two. I made number 7 up, so you just have to write it in. All right, number 6. Earthquake comes along, crushes this into 2 pieces. What's 12x divided by 4? 3x. What's negative 8 divided by 4? So all we did is we earthquaked it and broke those pieces down on top. How about 7 though? You got to keep track of your negatives. Conrads, what'd you get?
5x minus 2.
Yeah, negative 10 divided by negative 2 is a positive 5 x's. And then positive 8 divided by negative 2? Negative 4. Okay, very good. In the margin, they're going to use a couple terms today. I think just having this in the margin is going to be good enough for you. When they use the word mean, you guys have dealt with it before, but they're talking about average. To find the average of a set of numbers, you add them up and divide by how many there are.
Won't this be negative because the bigger number's the negative?
I think, didn't we say negative?
I mean
Yeah, we did.
Negative because this is a positive thing.
Oh, no. A positive divided by a negative is going to be negative. Okay? And the other thing, we've talked about it before, but just, it's kind of new for you again this year. When you see this term average rate of change, find the change, take new minus old, and then find the change per year, per month, whatever it might be. It's like finding a unit rate. So if I told you that, let's see, if I told you that Riley Ewell, okay, in 2000, when he was 2 years old, is that right?
Yep.
Okay, in 2000, he had $500 in his savings account. Okay, now we're in 2012, and he's got, oh, I don't know, he's got $100 million. Let's just start with $10,000. Okay, and I asked you to find his average rate of change. Well, how much did it change?
$950,000.
9,500. Divided by, because we're finding unit rate, how many years? 12. Whatever this number come out to be, that would be his average rate of change. On average, per year, he was saving X amount of dollars, whatever that number comes out to be. Okay? That's all we've got for today. So division and earthquake in it. Those were the big ideas.